Hi everyone, welcome to the next session of the Scalus Club. Today we have ops development and what's next on the upcoming inter-era hard fork. And we are happy that you have joined our session today. So we can start. So quick recall, Scalus is the Cardano full stack development platform using Scala 3. So Scalus provides everything you need to build on Cardano, starting from smart contracts to off-chain toolset, which includes transaction builder, Cardano Node Emulator, off-chain testing, and everything you need to run the application, which JVM ecosystem helps here. Today, our session will be around 1 hour 20, 1 hour and a half long. And we're planning to cover next topics. So first we'll speak about our roadmap and the news. And then we'll deep dive into DApp's development starter kit and how you can get inspired with the existing kit to start building with Scalus. Then we will showcase Cardano Emulator, the new version which has the support for JavaScript, TypeScript now. And then we'll deep dive into what's in the hard fork, and it will show you what can be done and can be achieved with alternatives and optimizations. Before we start, so yeah, if you have any questions, feel free to use the Q&A module. So put your question in, and after each block, we'll have this Q&A element to it. So we foresee like 15 minutes of presentation followed by 10 minutes of discussions and questions. Yeah, feel free to share feedbacks. I know some of you are using our platform and some of you are curious about using it. Linking to Kian. Yeah, if you see any capabilities or have any questions, see any capabilities that you would need or you're looking for your day-to-day ongoing development on Cardano, feel free to request things and we'll be happy to see how we can bring those to you. So I'll start with a quick overview of roadmap. We just finished the third milestone of our roadmap supported by Cardano ecosystem. That was focusing on off-chain libraries. So yeah, we made plenty of progress. So we have our transaction builder, which is working. We have Scalus JS exports, which I'll speak about a bit later. And we made some progress with integrations with some off-chain libraries. In the upcoming milestone, we'll be working on various testing capabilities. So our testing framework will evolve. We are progressing on property-based testing to strengthen the verification of your applications. We'll provide advanced data structures that could be used in production environment. We'll focusing on Patricia Merkle Forestry, on updated version of the linked list, and on the Radix tool 3. And we will finalize the remaining 6 to 7 use cases, examples that we are developing so that you can have reference implementations for those in our examples library. We have recently released Scalus version 0.15, and we are advancing rapidly towards version 1, which will be coming in the upcoming month or two, so March or April. Doesn't mean the platform is not production ready. It is, and just want to finish a couple of factorings and minor improvements around error management and some like tuning and cleanup before we release version 1. Yeah, what's in Scalus 0.15? So first of all, we have the support of the upcoming inter-era hard fork. So all built-ins and optimizations were implemented. We made a couple of cool improvements to our transaction builder, namely draft method for unbalancing a transaction assembly, and script context method to easily access script context. We were working to bring the Scalus capabilities to JavaScript and TypeScript. And the release of our emulator for JavaScript and TypeScript is here. We'll speak and show it a bit later. Developing the ledger rules. In this milestone, we have done a delegation and stake pool rules. The remaining part is governance. Today, while using Scalus emulator, you are able to validate your transactions offline without actually accessing the real or dev Cardano node. And this capability exists not only on JDApp, but also JavaScript and TypeScript. And we have finalized a couple of cool design patterns, provided reference examples and the starter kit. Yeah, speaking of those production-ready design patterns, so we have done parameter validation, Merkleized validator, and UTXO indexer, mainly one-to-many and multiple one-to-one, one-to-many. And you can find those in our... Wait, I'm not sharing the whole screen. Let me just reshare. Sorry. Up. So yeah, you can find it in Scalus Design Patterns package in Scalus platform. So you have the explanation of all design patterns, examples of implementation, some details, some things to note. Also on our website, you can find a design pattern section where we deep dive into each design pattern and explain more from the use case perspective, in which situation design pattern is useful and like how it works and how you can use it. So we have those design patterns explained. So feel free to browse and see the documentation and try it. We have developed the couple of new examples. So we added auction, crowdfunding, lottery, storage, betting, and escrow implementations. As well, you can find them in our examples library. So every new pattern and blueprint contains a smart contract. I'm sorry. Yeah, so smart contract, you have respected transactions, you have tests associated with them. And a couple of those we also provided optimized versions, which uses, for example, zero withdrawal trick. We are going to contribute those into Cardano Blueprint repository that is managed by Cardano Foundation, and also to the Rosetta Blueprint in the upcoming weeks. Yeah, as I said, our documentation got significant updates. So we have added a transaction section, which covers everything you need to build all type of transaction. So starting from step-by-step guide how to build a transaction, but also all types of transactions with examples. We have a new section covering testing. So it has unit testing, debugging, emulator, how you can actually use dev kit, and Alex will show how easy it became. Yep. And we have added the app development, where we start to collect various articles about the app development, specificities or features that you can use our platform for. We have the DApp Starter Kit guide, which helps you run, understand, make some modifications, and deploy. I'll just add, oh yeah, Matthew is coming. Yeah, so yeah, our documentation improves, and you can go there and check how things are running. From the integration, so one of the premise of Scalus was to contribute to Cardano development experience. And one of the things that we can do with Scala, we can export all those capabilities that we have on GVM to various platforms. And in the previous milestone, we were working on JavaScript exports. So we are building and maintaining a Scalus JS, which is a library which contains activation and cost calculation right now. But also we have emulator, and we'll continue building various off-chain tools in it. Our idea behind it is to not compete with other off-chain libraries. We know that there is a couple of pretty nice JavaScript or TypeScript libraries. Lucid Evolution, Evolution SDK, Mesh, what was Comet, I think. And what we are trying to do is to help them serve their users better. So in the previous iteration, we have made the integration with, so we collaborated with Mesh team and No Witness Lab team to get Scalus offline script evaluation and cost calculation implemented. So now while you're using Mesh or Evolution SDK, you can actually rely on Scalus cost evaluation and script calculation, cost script evaluation, I'm sorry, libraries. And we're collaborating right now with Mesh to get our emulator being implemented, allowing effectively Mesh do not use any online services to start building transaction or validate transactions. So yeah, those two integrations has happened. I also contacted TM to see if we can as well streamline integration into Lucid Evolution. So we'll discuss later. Basically, we're trying to expand Scalus capabilities, but also help other libraries to expand there, so we all together serve better the Cardano ecosystem. Scalus adoption progresses, and there are a couple news from the protocols that are using Scalus. And so we are collaborating with those Fluid tokens to build Coin Cardano Bridge, and the watchtowers and SPO communication programs will be using Scalus. We are right now in a specification phase of the Catalyst project, and we'll be starting posting various technical insights into how the protocol works. One of the articles which we recently posted on our website is about Frost protocol. So you can go to our website, which is lantern.io, and find an extensive explanation of how Frost works. If you'll be curious how SPOs will be signing Bitcoin transactions. On the Hydrozoa side, like George, if you will have time at the end, you can share some news. I'll just give a high-level overview. From our last talk, you shared with us that Hydrozoa is moving into integration phase and testing, extensive testing. And you're working with the team on building a couple of use cases and start the real use of the Hydrozoa protocol. The Hydrozoa protocol is lightweight state channels. It's kind of evolution of Hydro protocol. Yeah, if you want to learn more, you can check the video that's from the Nerd Out videocast, where George has explained what Hydrozoa is. Yeah, see it on the Nerd Out if you have time. All right, so I think that's all for the intro. Do you have any questions before we move forward? Yeah, go ahead.
You mentioned Frost. You're talking about the Frost, the threshold signature scheme. Are you guys planning to implement that in Scalus? Or kind of, is there or wrap some external implementation of it so it's accessible via Scalus somehow, or what's the plan?
Yes, the idea, and also what's interesting there is that we will need to do some KZG stuff, and we were thinking to reuse your work in Hydrozoa because you do KZG commitments.
Yeah, absolutely.
Yeah. So with them, the development isn't started yet, didn't progress into Frost implementation yet, but we'll be using it for Bitcoin Cardano Bridge. So yeah, soon it will be in our package. Any other questions? All right, let's start with our short demonstration and review sessions. And I'll let Alex pick up from here to speak about the app's development and our Scalus Starter Kit.
Thank you. Let me share my screen. All right. Do you see it, guys? I think so. Yeah, Giovanni, yep. Roast sleep will be usable from Java. All right. So the idea is to demonstrate a Scalus DApp library, and we have this Scalus starter project, which essentially is the idea behind it is to have a smallest app that has all the components. So here's the repo on GitHub, and here, what we have here, we have a maintenance policy, simple maintenance policy for a token. We have a transaction builder component. We have a CIP57 blueprint generation. Also, this is a backend application. It has a REST API and a test suite, including the integration tests that are run using Yassi Dev Kit. So that's the README of the project. And if we download it and set up it in here it is, let me walk you through the starter to show you what exactly is happening here. So we have a main file. It's exactly what it is. It's a command line CLI tool. So we have a command line parsing stuff that you can run that either starts a server or shows you a blueprint. The servers can be started in the Yassi Dev Kit or in a pre-prod or preview. So I can just run this, the main file, and it's going to start an AT server. And we can go to this URL. If we go to docs, here's the familiar Swagger UI. And we have this mint endpoint. We can try to mint something. So it's a tapir endpoint that essentially gets the amount and handles mints tokens. So let's see what's going on here. So we have this like on-chain module that has a minting policy and off-chain module that handles the API requests and transaction building. Let me show you the minting policy first. Again, you see, this is all a single project. You can mix everything in a single project in one language. That's one of our benefits. Minting policy, here it is. Let me stop it for now. There's a configuration of this minting policy with admin public key and token name. It automatically derives how this data type converts to and from data, so you don't need to worry about that. Just derives and that's it. Here's the minting policy. Easy. If there is a admin signature, you can burn or you can mint. And the signature policy is configured during the script parameterization. And also, just for fun, we parameterize the token name as well. Here's the script. Let me show you how it looks. So we have a inline mint. The inline means that the Scala will inline the body of this function into whatever is called. So we even don't have extra calls in this situation. So we just read from data the minting config and call this minting policy. This minting policy checks our own policy ID and expects a single token in tokens and require that its name is like this. Otherwise, we basically trace this error and exit. Yeah, no tokens is impossible. And extra tokens is an error as well. And we check the signature of the admin pubkey hash. That's it. That's the whole thing. And let me show you how we do transactions for this thing. So we have a transactions module, like simple class. And here we use our transaction builder to mint these assets. We don't need any redeemer. We just require a signature. That's the admin signature here. And we pay to ourselves, basically. It's very simple. Let's try to test this. So if we go to maintain policy test, it's just a simple Scala unit test. Runs instantly, as you may see. And it tests like the size of a script and all the cases. Like with this, the min should fail when the name is incorrect, blah, blah, blah. If there is a signature, we should succeed. And when we succeed, we even check the units, memory units and steps. So we can ensure that our script behaves exactly how we expect. And we even can calculate fees and expect certain fees from runs of the validator. All right. Another cool thing is that we can run this code as a Java code. So we can do breakpoints and do debugging as usual. We will later show this. Cool thing is that here we test this validator using script contexts. It's very similar to how Akin does it, but there is a caveat. So when we create a script context to run our validator, we actually use our transaction builder, and it's our new feature, which I want to demonstrate. So we can use a transaction builder to create a mint transaction. So we mint and pay to ourselves, and we use this draft method. Draft method does not balance transaction. It just creates whatever we previously set up as intentions to build this transaction. So it does not run the scripts. It does not go on any services. It's purely it's pure function, no effects, nothing. It just no dependencies. And this will produce a draft transaction from which we have a special method, extension method getScriptContext for this mint, because there are many script contexts. It is for spends, for mints, for withdrawals, etc. And we can get specific script context specific for this validator for minting. And this is very close to what's actually going to be this validator will see in production. So you can rely on certain properties of script contexts. So certain fields will be filled, etc. It's very handy, and you don't need to construct the script context yourself. You essentially can reuse your transaction building parts and use transaction builder to get these drafts and get these script contexts from it. So we think it's a very useful thing for testing. Check it out, use it. Also, we have a couple of nice features. We implemented a bunch of pretty printers. So we now have this pretty interface that you can define and basically instance, type class instance for it. And we have a default derivation. So if your type does not have a pretty printer instance, our macros will derive it for you. So you could do things like this. So if we run this again, we will see that this is a pretty printed data of this tuple. So it's tuple of a string in the true, converted to data and short highlighted. So it is a string and a constructor with one tag of one. And here's a transaction. It's a pretty printed transactions. We've got the output, we've got a mint, and required signatures. Yeah, and even scripts field and redeemers. So it's empty, but yeah, it's a draft, right? So it's very useful for debugging and to showing. So that's testing of the validator. Let's test the whole thing. For that, we have our implementation of integration of Yassi Dev Kit containers. That's quite, well, let me show you this first. We have implemented emulator. Last time we told you about the emulator. Emulator essentially tries to emulate a in-process Cardano node. It implements ledger rules, all phase 1, phase 2 validation, UTXOs, registration of staking addresses, stuff like that. So essentially, it could submit transaction to the emulator. And we use it for testing. And the idea is that we have this transaction emulator. Yeah. We have this transaction test base where you can define a test. Here we build a transaction minting transaction that mints 1,000 tokens. And we can run this test either in emulator or using dev kit. So here we run this test. It runs very fast because it uses the emulator, because we have this integration that essentially uses emulator to run this transaction. Or we can run the integration test. Let's do it transaction test. So this one starts a Docker container with Yassi dev kit there that contains the actual Cardano node, so Haskell implementation, so real deal, and runs this thing. And you have the same code to the same tests that are run in emulator or in Yassi dev kit. So same code. It's quite nice, quite handy. So you can do very fast iterations on your tests, and then you can check them on a real node when you wish to. And we have another test, which is minting test. That runs the whole flow. It's, again, mints some tokens and then burns them. That's the whole application flow idea. So we got this minting transaction. And we've got this burning transaction. I can show you this test. Yeah, so you can run these scenarios. Basically, create a minting transaction, submit it to either emulator or Yassi dev kit, wait for some blocks, burn, submit, wait, check UTXO, and ensure that there are no UTXOs here. Yeah, again, same code runs in emulator or Yassi dev kit or pre-prod or preview or whatever you set up as an environment. And this works out of the box. You don't need to set up anything. You only need Docker. Basically, I'm not sure even if you need Docker. I think it's gonna download it either way. All right, that's our tests. What else? Let me show you the blueprint. And we have implemented a blueprint, so you can print the JSON with the blueprint at any moment. Got compiled code, all the metadata and the parameter. It's a parameterized validator, so parameters are here as well, and it's quite easy to set up. That's the blueprint setup. All right. And yeah, I think that's it in a nutshell for the starter. So the idea was for you to, if you wanted to start development with Scalus, you download the starter kit and you've got everything. You've got the on-chain code, off-chain, transaction builder, test examples, test scenarios with integration tests, test with emulator, and Yassi dev kit, all in 8 files or 9 files. You can do full application just from this one project.
Yep. And when you will download the code, you will see that it's pretty well documented, so you can read it very easily. But if you have any questions, you can still go to our website and find in documentation the step-by-step guide about how to run it, how to read the information we got, show it.
Mm-hmm.
So you have the starter kit. So how to run it, like how to clone, how to test, what's inside, how it works, how smart contracts are developed. They'll also even have how transaction builder is done, how to test it, and how to make it own, like as well, how you can modify things. And at the end, you have what you need in order to use it, install it on testnet. So pretty neat project. So if you want to start and don't know what is needed to build a end-to-end decentralized application, here is an example. Do you have any questions? Let's deep dive into emulator to Sergey.
Hello. I'm gonna share my screen real quick. Yes, there it is. I'm not gonna show you much today. I'm just gonna reiterate on what Alex was saying about how emulator is useful for local development, because it is a local emulator of the node. However, it is pretty full in terms of the behavior, the node behavior that you need for your local development of contracts or protocols or whatever. You want several things. You want validation of your transactions, and you want for the state of the ledger to change because of your transactions. And this way you can chain them together, you can verify your flows, and you can do it really quickly, because the alternatives are Yassi, which is good, however, could be faster and needs Docker, probably needs restarts, and all this really makes your feedback loop a little bit more long. And the other alternatives are like testnet, which is good if you want completeness, but not that good if you want to iterate faster. And this is where the emulator lies. It tries to distill the things that are necessary for local development. The big part of it is the set of ledger rules. We aim to implement, we have implemented the UTXO related ledger rules, stake related ledger rules, and I'm pretty sure the eventual goal is to get done with the governance and other related things. However, the big ones are the withdraw zero trick that enforces the implementation to be able to handle stake registration. We do support it now, and all of the UTXO related stuff, which we also do. And thanks to the fact that we use Scala, we can export it to JavaScript relatively easily. This whole thing, the JavaScript emulator, didn't take long to implement, and the changes are going to propagate from the Scalus to its JavaScript API really fast. So I'm going to walk you through a couple of examples of how the emulator can be used from JavaScript. It's just going to be a couple of tests that are going to illustrate the ledger rules and how they are indeed, in fact, validated by the emulator. For the API, you can always head over to our website or to NPM and download Scalus yourself, but I'm going to show you in my text editor really quickly what it looks like. Emulator is pretty self-explanatory. It allows you to submit transactions. Currently, all of our APIs are CBOR based, whichever data type that you have in your favorite JavaScript library is probably not CBOR immediately, but almost certainly can be encoded into it, thanks to the fact that Cardano uses CBOR pretty heavily. So it can submit transactions and it can query the state, which is the UTXOs, from the address or all of them. And we can also manipulate the slot, which can be useful for local development as well. As for instantiating the instances of the emulator, you can do it using your CBORs, or you can, which kind of looks similar to how you would use the Yassi dev kit, you can just pre-initialize it with saying that each of the addresses has a certain amount of Lovelaces. We should probably also add I'm thinking whether we should add the multi-assets here. I'm not sure. Doesn't matter for now. And so to just show you for the nth time how it looks, we initialize the emulator using the factory method. We use it to query the UTXOs, we decode it, we check, we inspect the UTXOs that we have, and we use it to pay. Throughout this whole illustration and further illustrations, I'm going to use Mesh.js for building my transactions. However, you can use whatever you want. Maybe you can even build the transactions manually yourself. So we built it using Mesh's, the lowest level API that Mesh allows us to, which is basically we supply everything, right? We're developing locally. We don't necessarily want to query anything. Perhaps we have the outputs that we want to spend. We can just do it online. I feel like for local development, this works best. We make a transaction, we sign it using whatever signature mechanism that you have. Scalus, this is not the Scalus mechanism. However, Scalus does allow you to sign the transactions using the Mesh wallet. Doesn't really.
I'm sorry, may I include that we also implemented the HD deterministic hierarchy wallets, so we could now get the private public keys from mnemonics and derivation paths. So you could have a signer from a mnemonic using Scalus as well, and it's possible to use from JavaScript as well. Yeah, sorry.
Yeah, that's okay. That's a pretty neat thing, right? That you can have a mnemonic, which you do have if you use Yassi. You have the test mnemonic that is the source, whatever. And you have the derivation path. You can get all of the addresses that you need just with zero dependencies, just Scalus. Pretty neat, in my opinion. Getting back to the emulator, you use it to submit the transactions. In this case, we use CBOR. And then hopefully, fingers crossed, this is going to affect the ledger state such that when we query the emulator next time, we see that our payment indeed went through. What does it mean? It means that in this case, Bob, which has their own address, gets one more UTXO. If we run this thing from my IDE, boom, boom, we see that indeed Bob has this much levels in the transaction, and Alice she started with 10,000 ADA, she paid the fee thanks to the fact that we have created a valid transaction, and this transaction created two outputs. Pretty simple, not really useful on its own, right? Because it's just it's the simplest form. You couldn't use the ledger any simpler if you wanted. However, this is not everything that Scalus can do. Moving on to the next example, we're going to try to test whether indeed there exists a ledger state that validates something, doesn't just accept every transaction. How do we test it? Pretty easily. We can just go ahead and I'm just now thinking that this shouldn't be correct because I'm going to walk you through and explain why this demo is not what we're looking for, but later we're going to see that the ledger rules indeed work. So the test does exactly what the previous test does. However, it tries to resend the transaction twice, such that to validate the fact that indeed it does what I needed to do, right? It validates the fact that the inputs are spent and cannot be spent twice. So the unspent transaction outputs created by the initially here are no longer spendable by the second transaction because, well, they're spent. And thus the ledger state is indeed transited by the previous transaction. We can see that indeed I could clear up some logs. We need to see that the last log that we have here is whatever the emulator says is the error, and exactly pretty close to what the node would respond to, perhaps even verbatim the error. The UTXOs that we're trying to spend are spent already, so we cannot use them. This is all well and good. However, if you're developing anything of any use, you're probably going to need to use Plutus scripts. And when developing things locally, the main thing that you want to do is see whether there's an error and to fix it, right? Or not fix it, or perhaps make an assertion on it that indeed the validator does not allow the behavior that you want it to not allow. And the emulator, on the second note, perhaps your transaction builder is going to be the first component that's going to tell you that whatever you're trying to do doesn't validate. However, if depending on the testing strategy that you're going to use, perhaps you are going to have a test transaction in hand, encoded to CBOR, and you would really like for the ledger to reject it. And the following example illustrates just that. I'm going to apologize for the fact that I unfortunately, in my limited time, could not get Mesh to build a transaction with a Plutus script locally, because I don't want to supply any fetchers or anything like that, or any providers. I'm sure I could have done it if I invested a bit more time in it. And also, to perhaps fantasize a little bit, whichever JavaScript library that you're thinking of, your favorite one, when building transactions, probably requires some sort of block frost dependency, some sort of fetcher, some sort of provider, something to query the UTXOs to complete the transaction, or query the scripts, something with access to some ledger. The implementations are usually block frost. The block frost is probably your go-to. However, the motif of the whole speech is local development, and this kind of contradicts the premise. Emulator, in theory, in practice as well, but in theory, has every method every provider method, every method that needs to exist in order for the thing to be called a provider, right? It can query UTXOs, and it can submit transactions. It can also do several other things, but this is the gist of it. And if you open any, I unfortunately do not see the hands, so perhaps Alexei, could you help me? What was the question?
Yeah, we'll finish and then after that.
Yeah, great. Thank you. Yes, so the emulator that we're developing here can be used as a fetcher, provider, or whatever your JavaScript library calls it, using like a very simple adapter bridge that we can bang out in 10 minutes into Claude Code prompts. And regardless, getting back to my example, believe me, that this transaction includes an attempt to spend from a validator that always fails. And we're going to see just that. This UTXO, in theory, I could have made that without CBOR, but the gist of it is, when the test starts, some funds are locked behind a script that always fails. And so when we submit the transaction, we want to see the logs of the validator that fails. And so if we launch the test, we can see that when submitting transactions, this returns the submit result thing, which has these fields. And importantly, it has error and logs, if the error includes some logs. And indeed, if we look at the console, it says that to prove to you that indeed this logs something, and perhaps I can show you the code of this thing. It's 2 lines of Scala. Yeah, it's here. It's here. This is the test that I've used to do it. This is the validator that failed, basically. Trust me on it. And we see the log. Whichever logic triggered the error, you're going to see. It's going to be useful and allow you to iterate really quickly. Very important for local development. And also the fourth example, just to show you the validity intervals and slots. This test makes a transaction that has the following validity window. And we use the emulator API to advance the slot, to jump into the future. And thus, at the point of submission, the transaction is supposed to be the ledger is supposed to reject it with a useful message, hopefully. And the message is not in the console. But if I put it there, it's going to be there. Boom. Transaction is outside the validity interval. And here you see, exactly what happened, exactly what we've written. This is just a snippet of the whole set of ledger rules that it validates. Basically, the goal is to reject all transactions that the real node would reject. And our test suite kind of makes sure that this is indeed the case. And available in JavaScript, thanks to the fact that we are using Scala and can export it there. This is the current state of things. We take suggestions, we take pointers, whatever you guys need. Will be very useful to implement and give back.
A couple of things to add on, like it's a bit of look into the future. We will be later in our roadmap working on supplying the API for data set preparation. So for example, if you are setting up your application for extensive testing, and you would need to supply a bunch of UTXOs or actors with UTXOs or you'll be able to provide the test data set that you can load into your test environment so that you can run the scenarios and stuff. If you use the TX3, they have this kind of a setup section which allows you to provide, and Sergey has shown us the example how you can do it through code that will be providing some kind of format which you can load. Basically, you can download it somewhere and then you just provide it as a data set. We're also working with us right now to see how we can integrate and provide simulator as an offline provider, so that you can when you start the development of your transactions or your application in JavaScript, you don't need to query the internet, so you can start locally, iterate. When you are ready, you can swap from internal testing, local testing to integration tests. And in general, we had this discussion recently with the team that emulator itself looks like a provider. It's a special provider. We hope that we can make this collaborate and make this provider being available in a set of default providers for local development. Again, I'm looking at Kian as well here, since Anastasia Labs supports the Plutus edition.
You guys,
Otherwise,
yeah,
the
definitely try to integrate emulator as well and use it for fast local development. Also, just I wanted to mention that this is available right now. So the Scalus 0.15 is published on NPM, and this is included in that release.
Yeah. George, you had a question or suggestion?
Yeah, actually, this was a good segue into my question. I just wanted to say that the emulator is a really cool new feature, and particularly the fact that it's available in JavaScript opens up some really interesting opportunities, particularly for wallets, because you could, for example, you can query BlockTrust once to know what the real state is of Cardano blockchain. You can start up an emulator that's populated with that UTXO set. Then the user could interactively construct a chain of transactions, and he's interacting with it as if he's just building each transaction separately. But in the background, the wallet can maybe just remember the sequence of transactions and help by providing those methods that the front end can just continue to query the emulator state as if it's a provider, right? And then at the very end, this chain of transactions can be presented to the user saying, okay, this is overall the effect of this chain. Do you want to sign? If yes, then he goes in and he signs all the transactions and submits. So it's a whole new opportunity, I think, that a lot of wallets are going to enjoy being able to access using this emulator from Scalus. Good job, guys.
Exactly, that's the idea. Thank you. And it's obvious thing, but I wanted to say that this emulator will do phase 2 validation, phase 1 and phase 2 validation. So it's going to run scripts as well. So it's going to run scripts and ensure that the execution units are correct within budget, etc.
Any other questions or maybe suggestions or anything that we would need or you'd like to try with the... Okay, let's move to the last section of our review. It will be about what's next in the hard fork. Before Ruslan speaks, I'll just show the overview. So this is the list of what Plutus has as the updates. So basically, case expressions and optimizations. Then we have new built-ins, and then alignment of Plutus version 1.2 and 3 with different capabilities, which today actually is not allowed. Following as well the hard fork working group and the current state of the planning. So there is a readiness list available, and in terms of planning of release, I will show you the planning they show. So right now in February, there will be a sanction app update. There will be a track of readiness of various applications, node implementation libraries and stuff. And the current release is planned around March, April. We are still waiting, and there will be as well voting for hard fork, because now it needs to be approved on chain before before it's enacted. But the working group is meeting every 2 weeks and they are sharing the updates. So yeah, if you're interested in what's going on, you join it and intercept. All right, I will give the mic to Ruslan, who will update us about going on.
Okay. I will share my screen. 1 moment. Oh, okay. Are we see screen?
Yep.
Yes. Okay. So what it all about? It will be one ROSM hard fork, which planned to be second quarter of this year. It's interesting that it was mentioned as Plutus 4, but it is not Plutus 4 because all features will be backported, and we will be able to work with Plutus 13 with new built-ins. And that name is protocol version 11. But in our code, sometimes you will see Plutus language 4. We will turn up this, but for now, language is published. Okay, so what's new and what's interesting? We have a case on built-in types, new built-ins, and new types. How it's used in Scalus. At first, we just compile code, and we can compile code fast. Because when we have much on enum, we have, for example, we have enum like this. When we have few cases, and we have, it is the location on the board, one of direction. Formally, it is also stat solver. It is a standard benchmark, which exist for in Haskell, in Anakin, and in Ava. So we can benchmark all identical. And very much for now, what we do now, we for much generate sequels of comparison with integers. What we will able to do is to one single case. And this is dramatically impact performance because it's all one. Also the same with begin. It is also was sequence of if now one nice and with matching by data by type. Data. Before we use choose data built in, now we say case. And
Sorry, were they comparing big ints to 0, 1, 2, 3, 4 just iteratively before?
Yeah. Yep.
That's crazy.
Yes.
Oh my
That's
god.
how, but you have no other option basically.
yes,
Aiken
we have
does
no
the
other
same.
options.
Yeah. You could build these trees, but it doesn't make sense for usually it's 1, 2, 3.
Oh no,
cases.
I know. I'm just surprised at the craziness
It's
of Plutus.
horrible.
Sorry.
It's horrible. It's horrible.
It is many things, but what is interesting that we have a 50C CPU drop when change a case to sequence of these two cases. Also interesting is that the case on bool factually kill if the else built-in. We have built-in,
Yeah.
if the else which have force, but now
don't need
when we
it.
have case on bool, we can use it without force and without mechanic for polymorphism. It's just work and they work fast.
The funny thing is there is this UPLC Cape benchmark that implemented, and they published the first version. They published the Plutus script, and I implemented the same in Scalus, and I see like huge difference. I don't know, 5 times, 10 times. Why? What happens? And I just open the UPLC they generate, and they generate these cases on booleans, cases on numbers, on integers. And it's not implemented yet. Where did we get this? I wrote Yura, hey, it's cheating. You're using the features that are not available yet. And he changed it back, and it was like dramatically worse than Scalus. So now it's better.
Yes. The second thing which is interesting is field access. Maybe I know that when we have field access, for example, here is Techniphone, and we want Mint. Then in now and we and all other builders, how get Mint? They get tail here. And time we have things. And now with PV11, we can now call drop list. And this is also give us dramatically change in performance, because it is the same for 2. And then when we have 3rd or 10 element of scope, we use drop list, and we see the difference is quite interesting. And for benchmarks, we see that, yes, quite impressive. What you need is just to change a target language and receive a drop of budget. Motivara is...
Be aware that this will work only after the hard fork. So you can try it on, I think it's on preview right now. So it would work on preview and will work after hard work as well.
How do we select the Plutus version in Scalus? I forget.
I will,
If we want to try out
I will
these
solve
hardware features. Okay.
I will solve this in the next slide, on one of the slides. What is else is the value is native multi-separations. What is now, for now, we see that value is map on policy IT and map, so 2 maps and lists. And the work of this, we need unroll map, unroll list, inside list, and work with this. And this is machinery. But here we have quite fast lookups, and also we have automatic maintenance of invariants. So if we will try to insert second policy IT, we will receive exception. So it is very, and we have also nice built-ins for scalable. Interesting that convert to from data, it's live in data in the same way as it lie in data now, as a map of map. But we can't change without changing the language, we can change type of script context. We think that we will be able to fully use this after Plutus V11. But now we can maybe create the same for same.
I think we can create an alternative script context that uses the built-in value, right? Because it encodes to data the same way, right? So
Yes, we can. Yes, but the question is, are we allowed to change API? No, in general, if we are Scalus, we can say that we are Scalus, we are not Plint, then we can change API. But,
I think
it requires, we need to change API. No, we just...
Oh, are you saying you can use any kind of custom script context you want because you're interpreting it from data? Is that?
Yeah. Everyone can do this.
Yes.
Yeah.
Yes.
Yeah, that's cool.
Okay. And also we have when we can, but the problem is that it's quite be constant. List array is constant. So for example, when we convert when we get field access on then when we have walls manifest in program, then it is always better to use drop list. But if you have more than 3 field accesses, then we better use arrays.
So it's cheaper to convert to array and get by index starting from 3 elements, from index 3, basically, right?
No, it's no. 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 If you have 1 access, then it is cheaper starting from 17 elements. If you have 3 accesses which are sequentially, for example, 1 x 2, yes, then better array.
Okay.
And it depends on program. So we can't say that one representation is better than other without looking on program how it uses.
Do you know, are they planning to make the transaction inputs, transaction outputs, and all the other things into arrays? Because it's read-only data. Isn't it better to have it as an array from the beginning?
I hope in V4, but they cannot change it in previous versions, I think.
We can change it.
But
it is the same situation as with Mary. We can change because we have all the data, but Plutus Lint can change.
Maybe they will have this in V4 by default. They'll have the arrays. I hope. If not, it's another disappointment. Anyway,
Okay. And at least we now have integer, and we can do a starting verification, which was impossible before.
it's even cooler.
With,
Even cooler. We had an idea that required to do the elliptic ECP to 56K1 elliptic curve point operations on chain. And we don't have the built-ins for that. But with mod X, we can actually just implement the arithmetics of these point operations, and it's going to be decently performant. So finally, yeah, it's a good one as well.
So what you want to have in Scalus to use it? Just sorry, it's incorrect, but we.
Yeah, we'll
No.
put the protocol version there, and it's gonna.
Yes, but now we just need to target language pull switch there, and all will be run with better budget.
Yeah, that's essentially we'll use new built-ins. Yes.
Yes, for example, when we have pre-image validator, maybe
Very simple.
one
Yeah.
some post
Kind of HTLC.
yes. Then we see the difference with budget. It is compiled on OS3 with Scott and Cody representation, which is before, and then compile with data representation with latest enabled, and we have that latest wins. We have near 26% in C. But also we can use new built-ins in assembler mode, because in Scalus we usually tell that we work with the H level, we use all Scala types, since and list, but actually we can limit us to use only built-in types and use only built-ins and write something like assembler. And this is cool when we wrote something pattern protocol, which should be cheap or which should be evaluated millions times. And
currently, essentially, we have these two sets of users. One that use like Aiken to write high-level code, and Aiken is not awesome at performance because it's a high-level language, but it's you can write a lot in a small amount of lines, basically, right? And Scalus by default works like that. But if you want performance, what people currently do, there's a second set of people that use Plutarch, where you basically manually construct lambda calculus, right? And you use built-ins and you use like primitive types, etc. And they cannot do this. It's basically impossible. And in Scalus, it's possible. You can actually do this. And what Ruslan is talking about.
And we have two models for this. We have something like compiled assembler. When we have Scalus, we have functions and all, but we trying to use only built-in types. And we have direct to PLC when, like in Plutarch, when we just construct term and then eval it. And now let's look on this pre-image validator, which was optimized on Scott encoding. It is the same, but instead having from data realization, we just run unconst primitive, get sense, get tail from the pair, and write low-level script. And
it's still better than Plutarch. Still better than Plutarch.
Yes, and and now let's translate this. How it changes with protocol version 11. So, what we can instead this field macro, which we use. We can use a new offset off macro, which will give you just offset from, as maybe remember, offset off in C language. It is the same offset off.
Index of this field.
Notorious. Yes. And we can run better. And also, we can stretch this to 1000.
Mhm.
So,
Nice.
yes, it is maybe we can yet one optimization that we can use built-in on pattern match, but we have list, occasional list. But we see that CPU is better, but MEM is worse there. Why? Because here T materialize, T become easier. But in this version,
It's lazy.
T is only, always call it only if we call check notorious again. No.
Yeah,
No,
I
what
must
is-
say that usually writing this low-level stuff makes it like
It's very
surprisingly, yeah, it's much
Yes.
better.
And
But
so,
you need to know what you do.
Yes. With assembler plus duplicity is still better than high level, but it's still better to, and we can use. Okay,
Yeah.
now
If sorry, just all right, continue. Sorry.
now if you want to have complete writing, then let's work in Plutus and just construct term DSL for these pre-image options.
Yeah,
what
that's
we can
Plutarch
do?
basically.
Yes, but it's Scalus. Why? It's Scala. It's
No,
TypeScript Scala.
it's what people write in Plutarch. Like we can do this in
Yeah.
Scala if you want.
Yes, what we can do, we can use prefix instead of the combinator. We can use the prefix combinator, which can be typed in Scala or Scalus. So we can think how to move combinators to higher level, but for now we can write this only in term DSL. And we just can use translate to lambda calculus by hand.
Yeah.
And we can get one small improvement in 20%, 70%. So
If you want,
looks like if you want maximum theoretical maximum performance, then you can construct dealer to pair. Then you can construct the terms, use your own receiver combinators. But I think that eventually, because actually it was the same story with mathematical compilers. Now compilers inline loops better than people, and I think that a year or two, and the compilers will generate a PLC also better. If we will have time and inspiration to do this.
and we
But-
will. We have few ideas how to do certain optimizations, and I think we'll be able to unroll some loops and remove recursion at all based on data, based on actual data that validators needs to work with.
Yes. Basically, we have two most barrier. It is a recursion and it is a monomorphism. When we call function, we call data in sub-representation. It solves data representations. And
Same as
then each function receive and put unconst. What?
And we can remove this, yes, and we will.
Yes. Straight away, if we just for casual user, we can just enable a new language and with zero changes, you will receive. If you advanced user and write on assembler, then we have new build-ins which we can use. We have new macros which also we can use. And also, if you want, you can construct direct to PLC as in Plutarch, but this will be on Scala, and it also can be interesting. That's all.
Thank you, Rustam. So if you are interested in trying this out, get the latest version of Scalus and you can do it. And if you have any protocols that you would like to improve or optimize ahead of the wave before the releases, feel free to contact us. We are taking some optimization work and we're working with the apps and protocols to help them get a better results, better performance with their scripts.
Yep.
Yeah, and do not hesitate to recommend us if you know somebody who is looking for some help in this field. We have quite deep understanding of how to make things work much faster than they are.
Yeah, and if you want to try it out and something you have questions and you don't know how something works and how to start something, just ping us in the chat and we'll set up a session. Maybe it'll help you. Because Rusty wanted to try out testing framework and emulator for his Aiken scripts, actually, and we set up a testing environment. So if he write tests in Scala, uses Scalus for testing, but scripts are written in Aiken. That's totally possible. That works well as well. So consider.
All right. Any other questions before we wrap up? Yeah, go ahead.
Sure. I have a question regarding compilation determinism for scripts, right? I think that's a very important property because if two people have the same source code, but they can't agree on the script hash, then they might be sending their stuff to different script addresses and it screws up a bunch of things in very weird ways. I wonder if you could describe for us, what are your strategies for, to the extent possible, trying to make sure that compilation is deterministic, especially given all of the kind of advanced optimization tricks that you guys are using to try to squeeze as much performance as possible out of the compiled code. How do you do that at the same time, to the extent possible, making things deterministic?
So first of all, the compilation is deterministic if it's not. We had a bug about this because of hash maps fixed. And so it is deterministic and it's bound to a version. So if you use Scalus version, so combination of Scalus version, essentially in plugin and the library defines the script, similar to how Aiken version defines the compilation output, because it's deterministic and it doesn't change. So
we have as well this contract file, which defines which lowering mechanism you are using and which version of the Alex you want to show an example. So basically you have the contract itself, you have transactions which you associate with them, and also you have the special contract file that sets up the compilator with all the necessary parameters. So once this is done, your compilation is deterministic.
Yeah, it will change with different version, obviously, if we change.
Of course. But so you're saying that as far as besides that hash map issue that you've addressed, there are no real remaining spots in the compilation pipeline that might do one thing on Tuesday and another thing on Friday, right?
No.
If you don't,
yeah.
Let's continue. I patience later.
Alex wanted to stop sharing, but he quit.
Internally, actually, we have a problem because Scala is too big and we want to restrict operations which allow it to work for compiler. But this is work in progress. For now, it is we just can debug and we have no automatical enforcing of determinism. But I think that eventually we will reach this.
Yeah. So
yeah, that's a totally satisfactory answer. Obviously, like when you're working in a big language, you don't necessarily have control over everything. But as long as you guys have a strategy in place and kind of a plan to move towards determinism, and mostly you handled everything that you can, that you're aware of that might cause the determinism, I think that's pretty good.
I think if you see non-determinism within a version, it's a bug. It should not happen. So we do everything in the ways to avoid this. Another potential thing is different Scala versions. So I think that Scala version and Scalus version is the ideal, essentially. So the same Scala version, same Scalus version is going to be deterministic unless there is some bug. But we have not observed it. No, JVM does not matter at all. So we have not observed it. Yeah, it's only that bug we have since no issues. And we recommend using currently we recommend using 337. It's a long-term support Scala version. Yeah.
So. One moment. We have different hashes of strings. And this potentially can affect you, and GVM potentially can affect this for now.
Hashes of strings?
Yes. You can.
Oh, that's interesting. And why is it relevant to us?
No, because
because
maybe
hash
sometimes
matters.
we'll have a dictionary, and are we sure that always that ordering like lexicographics? It should be, yes, but not always.
Let's check this and ensure that we
Yes.
use ordered collections in this case.
Yes, yes.
Yeah,
We
good
will,
point.
yes, eventually we will want to write deterministic containers and then use them. But it is no time.
All right.
Okay, so
Cool.
let's wrap up. We're having what's next. So right now we're working on testing framework and property-based testing. We have updated Patricia Merkle Forestry library up to date with the recent fixes.
And it's included
We-
in Scalus. It was in separate project, and now it's included in Scalus. So it's going to be in next probably minor version included.
Yep. Will be also one cool thing that we will be working on is the radix 2 tree, which will help in the situations when there is two branches. Radix can help.
No, it's the current situation is that everybody uses Merkle Patricia Forestry made by Matthias, and it's not good because it's radix 16, and you need to provide extra proofs. So your proofs are larger than necessary because you need to provide 15 neighbors for proving. But the radix 2 was not that big. It was not possible to implement because we did not have bitwise operations in Plutus, and now we have them. So now we can implement the radix 2 try, and we will have probably the first one, the first and the best implementation of Merkle Patricia try.
Very useful for protocol development.
Yes.
Who rely on Merkle trees and extensively for pushing presence and absence of something in the tree.
Mhm.
Then we'll be providing some examples like of more complex applications and use cases like INN and Simple Vault. So there will be like 3 other patterns that we'll implement within the next milestone of our budget. And yeah. So as usual, ping us on Twitter or Discord if you have any questions or would like to try something. If you are building something and you want to use Scalus, don't hesitate to contact us. We're doing short consulting sessions to help people kickstart. Yeah, next session would be in the middle of March, and we're going to Builderfest. So if you are joining Builderfest, we can see each other there on site in March. Don't forget to join the club. So if you want to receive the updates when the next session is happening, so click subscribe. And if you can help us to share and spread the word about Scalus, its readiness and what we are doing, it will help us as well with adoption. So yeah, thank you for your time, and yeah, see you next time.
Thanks, guys. See you next time.
Bye.
Bye.
Should we stop recording? Wait a second. It doesn't work. Stop recording.